Mr. Smith again. In this video I'll be finishing up the test 5 review. So let's get started. On 29A it says write the statement below in symbolic form. Assign letters to simple statements that are not negated. So make sure your statements are not negated. Construct a truth table for the symbolic statement in part A. Use the truth table to indicate one set of conditions that makes the compound statement true or state that no such conditions exist. So I'm in class, we'll call that statement P, or I'm studying, we'll call that statement Q. Notice both of those are positive, they're not negated. So P, I'm in class, and Q, I'm studying. And then here we have and, which we know is going to have that symbol. I'm not in class. So notice that's not P. In the or statement here, we use this symbol. So write the statement in symbolic form. So I'm in class, that's P, or I'm studying, that's Q, comma. That indicates that this should be in parentheses, this disjunction, this or statement. And I'm not in class. So that would be not P. And so here's the statement that we're going to construct a truth table for. Let's go ahead and do that. So in this case we have to build it. So I'm going to go ahead and write it right here so we have it in front of us. So first of all, I'm thinking I want to get P or Q. I'm just going to kind of work from left to right here. And then I'm going to need not P. And then I can put these two together with an and statement. So it'll be the final statement. Okay, so P or Q we know is usually true. It's when they're both false that it'll be a false statement. So if there's at least one true statement of the two, then we have P or Q is true. So only false when they're both false. So not P will be the opposite of our P column. So false, false, true, true. And then finally we're going to do an and statement with these two here. P or Q and not P. So we know an and statement is usually false. It's only true when the both statements are true. Otherwise, it's going to be false. This was the only case where both statements were true. Now, if you go back to the question, it said we need to find one set of conditions that makes the compound statement true or state that no such conditions exist. So that would be this case here when P is false and T is true. So I'm going to go ahead and answer C here. The statement is true when P is false and Q is true. False, true. Yep, that was correct. Number 30, use a truth table to show that not P or Q and P implies Q are equivalent. All right, and then we'll use that to rewrite this sentence. So actually we can go ahead and do this part. We'll go back and show that these are equivalent. So the triangle is not isosceles. So if we want not P, P would be the triangle is isosceles. You may recall that's when you have two equal sides in a triangle. Or, of course that's like that, it has two equal sides. So Q, the triangle, has two equal sides. So notice if this is statement P, but it's not isosceles, so this would be not P or Q. It has two equal sides. So notice it's got this form here. So to write an equivalent statement, we need to just write P implies Q, or if P then Q. So it would be if the triangle is isosceles, then, and we'll just say it has two equal sides. Now the wording doesn't have to be exact. You could have said then the triangle has two equal sides. There's some variation just because of the English language and how we communicate or talk using English. So let's go back to the other sheet and we'll show that they're equivalent. So that's right here. So first of all, I need to find not P. It's going to be the opposite of my P column. So false, false, true, true. Not P or Q, that's an or statement with these two columns here. So we know or statements are usually true. They're only false when they're both false. So there's no other false, false. So if there's at least one true, it's a true statement. And so finally, we have P implies Q, basically this part here. So we know an if-then statement is only false if you have true, false. So this would be false, and the others would be true. And so notice, not P or Q, and P implies Q, notice we do have the same truth values, and so yes, they are equivalent. We can say not P or Q is equivalent to P implies Q. All right, let's continue on. So we said yes. Or wait a second, did I do, no, that I didn't do that one yet. We just did 30 and we showed that they were equivalent. Let's look at 31. We got to do another one like that. In this case, number 31, we got to see if they are equivalent. So we want to know if not P, if and only if Q, and not P or not Q are equivalent. So we know that P, if and only if Q, is true if you have the same truth values for P and Q. So we have true, true, so that would make this true. They're not the same here, so here we're false, here we're false, because we have false, true, and here again, they're both false, so we would have a true statement. So if they're both true or both false, then we have a true statement. Otherwise, they're false. Now, not P, if and only if Q, is just going to have the opposite truth values. Not P will be the opposite of our P column. So false, false, true, true. Not Q will be the opposite of our Q column. So we'll have false, true, false, true. And so finally we have not P or Q, that's these two columns here. Now or statements we said are only false when they're both false. And it looks like that's the only time they're both false, so these are all true. So we have false, true, true, true. So are they equivalent? I lost my highlighter. So that would be this column here and this column here. We have false, true, true, up, false, true. These are not the same. So here the answer is no. They are not equivalent. You can see that from the truth table. All right, let's go back to our worksheet. All right, so I gave you guys a cheat sheet basically that's got the conditional and the other forms. So you're going to have this to refer to. I'm going to go ahead and put the answers for these. Oh, let's see. So basically with the converse, it's in the opposite order. This is my P, this is my Q. So it'll be if I pass all my courses, and I put a my in there just to make it sound a little better, then I work hard. So it's just the opposite direction. Inverse is the same statements, but they're both negated and we're going in the same order. So if I do not work hard, then I will not pass all my courses. And then finally the contrapositive, we negate this one. So we basically negate them both and reverse the order. So if I do not pass all my courses, that's not Q, then I do not work hard. We learned that the original statement, the conditional, and the contrapositive are equivalent. All right, so there's another example here. So again, switch the order, go the opposite direction. You have if today is not a holiday, then I am in class. The inverse is if I am not in class, this first statement negated, then today is not a holiday. Or no, I'm sorry. Oh, I didn't negate that one. Today is a holiday. Oops, I'm just going to go ahead and fix that right now. All right, the contrapositive, if today is a holiday, so we negated this one and we're doing the opposite order, then I am not in class. So we negate them both, put them in opposite order. Again, this original statement P, if P then Q, and the contrapositive have the same, or I should say they're congruent. All right, let's move on to number 34. So write the negation of the following statements. If I eat spinach, then I will be healthy. If I do not eat pizza, then I will not be happy. All right, well, again, you got your cheat sheet here. The negation of P implies Q. So basically here we have P and Q. So if P, then Q. The negation, according to our sheet, is P and not Q. So basically, with a conditional, if P is true, then Q follows. Then Q will be true. But to negate that would be to say that you have P and you don't have Q. All right, so here I eat spinach. And I will not be healthy. I'm just going to say I am not healthy. So that would be the negation. Oops, and you can't see that. And this last one, I do not eat pizza. That's P. So this is basically our P statement, although it is a negation statement. We have this, and we don't have this, or which would be not. So in this case, we would say if I do not eat pizza, so this statement is true, and let's see, we need to negate the second statement. I am happy, or I will be happy. Something like that. So again, basically the first statement, we have that. It is a negation, but that's okay. We're just going to repeat that statement with an and, but then Q we don't have. So it'll be the opposite of what we have here. We're going to negate this statement, so that would be I am happy. All right, let's move on to the last page. So it says, use De Morgan's laws to write a statement that is equivalent to each statement. I think I'm just going to put up the answer to this one here. So in this case, it is not true that Dallas and Texas are cities. So this is an and statement. Now, when we see it's not true, that's basically a not in front of parentheses, in this case where we have an and statement. So this would be, so basically Dallas is a city and Texas is a city. That's my P and Q. So you basically say it's not the case that Dallas is a city and Texas is a city. That's how we would interpret this. And that's equivalent to not P or not Q. So Dallas is not a city, or Texas is not a city. Similarly, on this one here, you have an or statement. Notice it is not true. So again, we're going to put that not in front of parentheses, that Scott Fitzgerald was a musician or an actor. So basically, Scott Fitzgerald was a musician or an actor. It's not true that he was either of those. And that's equivalent to not P and not Q. So Scott Fitzgerald was not a musician and he was not an actor. So basically what you see with each of these is, in this case, the or statement turns to an and statement, and the not here ends up being on both of P and Q. If you look at the first one, same thing happens. You have not out front, and then you have P and Q. The and becomes an or, and the not goes with P and Q separately. All right, but you'll have it. It's on the formula sheet. You just need to know how to interpret it. All right, let's move on to 36. Use a truth table to determine whether the symbolic form of the argument is valid or invalid. All right. So first of all, we have to know how to write this as a symbolic statement. So basically, these are our premises. We have P implies Q, and we have not Q. And we want to know if that leads to the conclusion of P, or if these two premises imply P. And so this is the statement that we need to check in a truth table. Oops, so let me see if I can find the right paper here. All right. So we said the statement was P implies Q, or if P then Q, and not Q. if that's all true, then we can conclude that we have P. So that's how we translate this. And so I've started you off here, and we just need to complete this truth table. So we have P implies Q and not Q, so we need to actually put these together to build the statement that we have here. And then we want to know that all of this, or if it all, implies P. So we'll have the final statement here. So if P, then Q, we know that's false if we have true false. Otherwise, it's true. Not Q, we're going to have the opposite of our Q column. False, true, false, true. So we want to know if we have P implies Q and not Q, if we put an AND statement together with those two statements, what is our truth values? Well, remember, with an AND statement, if they're both true, then we have true. Otherwise, we're going to have false. All right, so finally, we want to know if this implies P. Now, you could draw an arrow back this way, but I think what I'm going to do is I'm going to put P right here, and the truth values are true, true, false, false. And basically, I want to see if what we have here implies what's here. Now, remember, so we're basically doing this here. We want to know if this statement implies P is true or not. Remember, if we have true false, then it's a false statement. But otherwise, it's true. So in this case, this is not a tautology. And so this is not a valid argument. Argument not valid. So this argument is only valid if we get all truths here, or it's a tautology. All right, last problem, number 36. So we can solve 37 and 38. We can solve 37 and 38 using the same technique that we just did there, but we also have this table here that shows us the standard forms of arguments, and if these are any of these forms, we can see whether they're valid or invalid arguments. So we have Tony plays, we're going to call that P. The team wins, that's Q, so what we have here is P. If P, then Q. Whoops. The team won, well, that's Q. So again, the language, it could be present tense or past tense, but you basically have the same statement. It's still considered statement Q. So can we conclude that Tony played? That would be statement P. So let's go ahead and look at our forms of arguments. And notice it's this one here. P implies Q, and we have Q, therefore P. So translate each argument into symbolic form, then determine whether the argument is valid or invalid. You may use a truth table, or if applicable, compare the argument's symbolic form to a standard valid or invalid form. And so what we found here is we have the fallacy of the converse. So this is not valid, and it's fallacy of the converse. All right, last one. So if you didn't get these, you might try 38 and then watch the video and see how you did. Okay, so if you have good hand-eye coordination, so there's your P statement, then you can become a good hitter in baseball. There's your Q statement. So we have P implies Q. Todd does not have good hand-eye coordination, so that would be not P. Therefore, Todd cannot become a good hitter in baseball. So therefore, that would be not Q. Okay, so is this a valid argument? Well, let's pull out our table. We have P implies Q and not P. P implies Q and not P, therefore not Q. So this is an invalid argument. Invalid argument. And again, we have a fallacy. This is the fallacy. What did I do for the other one? Oh, did I get them mixed up? Let's see. Oh, that was different. This is this one. It's fallacy of the inverse. It's this one here. P implies Q, not P, therefore not Q. So it's fallacy of the inverse. So we could have any of these false argument. Well, these are all valid and these are invalid. But if you find these, and you'll have at least one like this on the test, you just have to identify which one you have and whether or not it's a valid or invalid argument. All right, so that's going to be it for this review. And if you have any questions, let me know. And that's it.